If I take a look at this next one, it says, what is the solution of the equation? And here I just want to solve, and I've got a radical in it. And when I have a radical, the first thing I want to do is isolate the radical. And notice this is my radical term. I want to get that thing by itself. And the only thing that's in its way right now is this -5 that's hanging out on the end. So we got to get rid of that guy. So in order to get rid of a -5, I have to add 5 to each side. So I'm going to add the 5. So what I'll be left with is the square root of x plus 4 equals 7. And now from here I have to undo the radical. Remember, to undo the square root, I'm going to square each side. Remember, radicals and exponents undo one another. The square root and the squared cancel each other out, so I'm just left with the x plus 4. And then over here, 7 squared is 49. And now I just have to finish solving for x. So I've got to subtract the 4 from each side. And I'll find out that x equals a 45. And that's it. I can easily plug this back in and check, which I should do just to make sure, because I will get extraneous solutions on this. So if I plug that back in, 45 plus 4 minus 5 equals 2. So that's 49. And the square root of that is 7 minus 5 does equal 2. So now I know for sure that it works. Okay, you can get extraneous solutions, but the 45 does work. For the next one, I want to simplify the powers of I. And remember, all powers of I will simplify to one of 3 things. Remember, we have this pattern: I to the first is I to the second is -1, I to the third is -I to the fourth is 1. And then that pattern continues. Right? I to the fifth would be back to I to the sixth would be -1, I to the seventh would be -I to the eighth would be 1. So really, we find this pattern that repeats forever, kind of in each direction. And what we want to do here, it's simplify this power of I. And the key to unlocking this is this 1 right here. See, every fourth exponent, the pattern starts over. So every exponent that's divisible by 4 lands us right here when the I value is 1. All right? So what we essentially want to do is find the closest exponent that's divisible by 4. So if I've got I to the 271, the closest exponent that's divisible by 4 is 272. And in order to do that, remember, if it's to check to see if something's divisible by 4, we just look at the last 2 digits. So for this one, 72 is divisible by 4, therefore the whole thing is. So that means I to the 272 would be equal to 1. So if I to the 272 is right here in my pattern, 271 would be back 1 in my pattern, which brings me to -I. Okay, so that's the answer I'm looking for. So again, we find the closest one divisible by 4, that's equal to 1, and now we count forwards or backwards in our pattern to get to the value that we want. If I look at the next one, it says to simplify the expression. This is just FOIL, or our distributive property rather. So I'm going to rewrite it down here. So I distribute the 7. That's going to give me a 14 minus 49 I, and I should have given myself a little bit more space. Let me try again. 14 minus 49 I. And now I've got to distribute the 4I, which that is going to give me a plus 8I minus 28I squared. And of course, I'm not done yet. I would combine like terms here. And when I combine like terms, that's going to be 14 minus 41I. And now I have the minus 28I squared. But we have to take a moment here. Remember, I squared is not acceptable. If I go back to the previous problem, I squared is one of my powers of I. have to simplify. I squared is the same thing as -1. So instead of I squared, this is times a -1. So now I have 14 minus 41I. This is going to end up being plus 28. And now I have more like terms to combine. So keep that in mind. Make sure you simplify this all the way. Do not leave any powers of I in there. That's going to be a 42. So I have 42 minus 41I. And now it's simplified as far as it can go. Now it looks like a complex number. Okay. For the next one, it gives us the perimeter of the triangle, and then it gives us 2 sides, and we want to find the missing side. All right, and I don't know what that missing side is, so I'm going to call it something like I'm going to use a capital A, so this way it stands out and I don't get it mixed up with stuff. But remember, the perimeter, we just add all the sides together. We add this side plus this side plus this side. That's how we find perimeter. It's all the sides added together, so -2x minus 9y plus, I've got a negative 2x plus 8y plus my missing side, which is the a, and that's going to equal my perimeter. Well, it tells me in the problem that the perimeter equals 1x plus 1y, so this is x plus y. And now I just need to simplify and solve for a, and really, that's just a matter of combining like terms. So I'm going to combine the like terms here. That's going to be a negative 4x minus y plus a equals x plus y. And now from here, I just have to solve for a. I got to get rid of the x, got to get rid of the y. So for the x, I'm just going to add the 4x to each side. So I add the 4x to each side. So I've got negative y plus a equals 5x plus y. And now I add the y to each side. So I find out that a, my missing side, equals 5x plus 2y. And that's it. All right, my missing side is the 5x plus 2y. So this guy right here, I'm gonna erase that, put my missing side in, 5x plus 2y. That's all there's to it. And really, we're just testing to see if we can add and subtract polynomials here. Okay, combine like terms. That's it. For this last question, this is one that we've dealt with a lot. We want to find the vertex, axis of symmetry, y-intercept, x-intercepts, and we want to graph the function. All right, and here's our function. I went ahead and copied it down here for myself. To find the vertex, let's start with the vertex. The x value for the vertex, I have to do the opposite of b over 2a. So the opposite of b is a positive 3 over 2 times a, which is 1. So that's going to give me a 3 halves. And now to find the y value for the vertex, I just plug that back in. So I plug the 3 halves back into the equation. So I have 3 halves squared minus 3 times 3 halves minus 10. So that's going to be a 9 fourths minus, this would be a 9 halves, which is 18 fourths minus 10. So that's going to be a negative 9 fourths minus, this is going to be like a 40 fourths. So that's going to be a negative 49 fourths. So my vertex here is 3 halves, negative 49 fourths. And to be honest, I'm not going to leave it like that. This is the one situation where mixed numbers are helpful, or decimals. If you want to write it as decimal, that's fine. So that's 1.5, and then this is negative 12 and 1/4, because I'm going to be plotting these on a number line. So there's my vertex. So that looks good. My axis of symmetry, remember, is always x equals, and it's always x equals the x value from the vertex, which is the 1.5, or, again, if you had left it as the 3 halves. All right, so it's x equals the x value from the vertex, and that's it. The y-intercept, remember the y-intercept is when x equals 0, and when we're in our standard form, the ax squared plus bx plus c, remember it's always the c value. It's right here, it's the negative 10. Okay, so the y-intercept is a negative 10, which of course as an ordered pair would be 0, negative 10. And writing it that way just helps us when we're ready to graph it. The x-intercept, or the y-intercept is when x equals 0. The x-intercept is when y equals 0. So right here, if I've got x squared minus 3x minus 10 equals 0, I just have to solve for x. I'm going to build a bridge. That's a negative 10. The two magic numbers are a negative 5 and a positive 2. So this is going to factor into x minus 5 and x plus 2. And now I set each factor equal to 0. Okay, so essentially I'm just solving for x the same way I did earlier in this packet. So I find out that x equals 5 and x equals negative 2. Again, as ordered pairs, this would be 5, 0, and this would be negative 2, 0. And now I just have to go up and graph all this stuff. The vertex was 1.5, negative 12 and 1/4, which is right about here. Okay, it's off my graph a little bit, but that's okay. The axis of symmetry is the dotted line that goes right down through my vertex, and that's why it's x equals, because it's the equation of a vertical line. The y-intercept is negative 10, which I can then reflect that point using my axis of symmetry. The x-intercepts were a negative 2 and a positive 5, and now that's enough information to graph. And that's it. I hope this was helpful, and good luck on your test tomorrow.